Crew members are eager to work with one developments that are on the agenda for Expeditions 28 and 29.
And all these experiments are connected not only but also to how materials that the space station is made of will behave, how new systems, future systems of future space stations and future interplanetary vehicles will function.
But in addition to that, there is a great deal of research that's directly focused on planet Earth, on improving life on planet Earth, on material science, combustion research, making cars safer, better ways to predict, natural disasters. There's all kinds of work like that that's being done on board.
With the astronauts and cosmonauts serving as laboratory assistants for scientists on the ground. In one instance, a scientist is using cucumber seedlings to learn how gravity affects the distribution of a plant hormone called auxin.
So, by knowing how the auxin distribution is controlled, we may be able to control the plant growth, or it may make way for the future plant factory in space.
In another, the researcher is trying to gain new insight into the structure of fire.
But we can control different variables then. They can measure this flame and gain insights into the physics, the fundamental physics of that flame. And if they could find a way to make burners, industrial burners, 0.5% more efficient, it would save millions of dollars a year and lots of energy.
The crew members will work on research in physical science, technology development and demonstration, earth and space science, and biology and biotechnology, while also serving as test subjects for the continuing research into how people can live and work effectively in the absence of gravity. In the case of flight engineer Sergei Volkov, who commanded Expedition 17 3 years ago, they'll be able to put experience to good use.
Now, with your knowledge, your experience, and analysis from the ground, you may see the improvement, or actually my expectation, to see some improvement in some experiments.
The science work comes in combination with ongoing station care and maintenance, plus some special events, including the final visit from a space shuttle orbiter. On mission STS-135, Shuttle Atlantis will carry as much supplies as can be packed into a multi-purpose logistics module and the middeck. But what it's bringing up is only a part of the story.
There's a lot of space shuttle-related items that we keep up there permanently from flight to flight. After this flight's over, there'll be no reason to have them up there, so we'll bring a lot of those home as well. So largely it's a cargo mission. It's an effort to posture the space station for about a year, put it in a good position until we can get our commercial cargo resupply system up and running.
Along with the supply mission, Ferguson's crew will support a spacewalk by Garin and Fossum. They'll move a failed pump module from a station storage platform back to the shuttle for return to Earth and failure analysis, deliver the hardware for a future test of robotic refueling capabilities, and finish other tasks as time permits. When Atlantis undocks from the International Space Station, the last shuttle undocking ever, it will mark the end of an era.
Perhaps in the future we will have more developed vehicles, but the shuttle will remain in history as one of the most successful vehicles in the history of the cosmonautics.
Whether it's deploying the Hubble Space Telescope, repairing the Hubble Space Telescope, building the space station, all the satellites that launched, all the satellites that recovered, all the scientific experiments that were conducted on board, I think I am really proud to have flown on the space shuttle and to be a part of the space shuttle program.
But I do believe that the future lies with such systems as the space shuttle and the Buran vehicle. 10 years may pass, or maybe even 20, and our technologies will allow us to create such spacecraft in a short amount of time and much cheaper.
One of the first tasks of the post-shuttle era will be a spacewalk by Semikutiaev and Volkov to reposition a cargo crane from the Pirs module to support future station assembly.
and we will uninstall one of the trailers from the docking compartment and bring them to the MRM2. That's also its biggest task. Probably takes like 1 hour and a half.
They'll also install new communications equipment, change out experiment samples, and release a student-built satellite. Expedition 29 begins in September, when Semikutyaev, Borisenko, and Garin return to Earth, and Fossum becomes station commander. The crew complement returns to 6 in October with the arrival of another Soyuz spacecraft.
The guys that are joining us coming up, Dan Burbank, Anton Skoplarov, and Anatoly Ivanishin. I've worked with those guys a lot too. They're great friends, and look forward to doing good work and having a good time and coming home friends when everything's said and done.
That crew will spend some of its time preparing for the test flight of a new commercial cargo ship.
The commercial vehicle is called Dragon, made by SpaceX private company. It is a very nice vehicle, nice cargo vehicle. It will supply spare items for experiments or water or food.
Dragon's test flight is targeted for late in the year, before the first test flight of another commercial vehicle, the Cygnus spacecraft, which is being developed by Orbital Sciences Corporation. They will join forces with cargo ships from Russia, Japan, and Europe in supporting the ongoing mission of the International Space Station.
This kind of material science, life science, biologic, the basic physics, those kind of things, are worth doing. And I think it's really part of our destiny to be reaching out, to be exploring wherever that unknown is located. Some people explore the depths of the ocean, some people explore the heavens.
The crew of the next Soyuz spacecraft currently at the launch site in Baikonur. Soyuz Commander